They're starting to gain a little bit of a charge now, thank goodness. I did pull out my harmonica today, but it needs cleaned, which means I need to completely disassemble it, wipe it down, get any dust or debris that might be stuck in there, pocket lint, belly button lint, whatever. Alright, so this video is about geology, geography, and brown people. Some of y'all might think that's racist to say brown people. Well, not every brown person is Mexican, okay? So, brown is a better descriptive. Not everybody here who has helped me has been Hispanic. Not all of the brown people here who have helped me are Hispanic. Just most of them. Some of them are actually natives. The situation in Hardin, Montana, that was a bunch of natives that took care of me. Anyway, I only got 6% charge on here, so it ain't gonna last long. What I'm gonna do is I'm gonna flip the camera around and we're gonna take a look at some really cool rocks. Fucking Christ. Alright, so this one right here, it's actually broken into pieces, but you can see on the inside there's some shininess to it. That part right there. And this is the part where it matches up on the other side. This is actually really high in gold content. That's where a lot of the black sand comes from. It fractures along fault lines. You notice that the fault line on this is curved. Oftentimes that's indicative of having a fossil in it. But normally what do? We go off into the woods, or we go off underneath the bridge over there, and we try to hunt for dinosaur bones that, of course, may or may not actually exist in the area. Now, these are all river rocks. This is a different thing altogether. These are brought from elsewhere and brought to the area. This is imported. There's a lot of really cool stuff here. This is an area that I was looking at earlier. You see that white rock right there? That's a piece of soap. That's actually what brought me to actually look in this particular spot earlier. Now, when I was looking at it, this one's got some really cool patterns to it. Especially right here, you can see there's, well, it looks like the fracture across, and of course the bump that's prevalent from it, you can see it right here. That's, of course, a fault line that had something in it. So, what's that particular shape look like? Alright, we got different types of rocks here, of course. Some of these, like this one right here. This one has got a lot of quartz content in it. If you're going to make a campfire, of course, like I said, this is just river rocks. You can find these just about anywhere. This one right here is going to be high in quartz, though, so you don't want to use that as a fire rock. It'll explode. And, of course, you don't want a rock that is 800 degrees exploding in your general vicinity. It's going to hurt a lot. Now, this one right here has got a lot of character to it. You can actually see that as it was forming, you can see the different layers and the different stuff that was going on at the time that it was formed. And then, of course, it got, well, like them ones that we saw earlier that were all jagged. Well, once they go into a river, this is what the sand and the water and all that breaks it down into. Something about like this. Of course, this is a pretty green color, and that stuff up there is mostly brown and black. We also have a lot of volcanic stuff in here. You know, that's what this stuff is. You can see the pock marking in it. You can see a lot of the rust on it. That's, of course, iron ferrite. Ferrous metals are magnetic, just so you know. If you hear the word ferrite, it means that it's magnetic. Now we can see that this one right here has a lot of pock marking in it. This one's got a lot bigger pock marks in it. Now, how long it takes to cool, these pock marks are actually bubbles that are in the, when it explodes, those are created. Now, if it's a magma flow instead of something like this that blew out the top, a magma flow, the stuff that's underneath potentially turns into volcanic glass. Those of you who are into Game of Thrones, they call it dragon glass in that. But We don't live in Game of Thrones. Here on planet Earth, it's called obsidian, and it's one of the best rocks out there. Now, we were talking about the piff, the paff, and the puff, right? This rock right here has a lot of character to it. Now, the piff, the paff, and the puff, that's different degrees of iron that's deposited within any degree of rock. When they make castles, they actually separate it based on the color, because the color tells you how much iron is actually in it. But this one, you can see there's different shapes within it. And of course, many of those shapes, they follow the exterior line of it, right along here and along the bottom, which means this right here wasn't actually formed originally as a river rock. This one right here was actually something that was within a void in, well, possibly like we were looking at these volcanic rocks. You see this hole right here? There was a bigger one, much bigger one, and this would have formed inside of it. Now this one right here, we can see all of the dark coloration to it. You can also feel that it's different. And we got a taste test. I probably shouldn't taste this because we don't know how many drunks have been out here drinking and pissing on these rocks. So we're not actually going to lick it to see what alkalinity it has. This rock right here, we can see that it's got a vein through it of, let me feel that. That actually feels more calcium than quartz though. So I'm not sure about that. I might have to set this rock to the side and have somebody check it out for me, because like I said, I'm not a geologist. Now of course in this area, one of the things that I keep pointing out, and I know you guys are probably sick of it, especially y'all crackers and whiteys, and you don't like those words, do you? You don't, I can tell. It's not nice when it's done your way. Oh, yes. This one also popped out with a nice shape. Now, what is it that was within that? What was contained within it that gave it that fault line right here? This is where the fault is, but this is where the break is. It's a good question. That's one of the ways they find fossils, is by studying the breaks and seeing, well, how and why. When we were looking at that thing earlier that might have been a thigh bone from a theropod. Now, of course, I'm not a dinosaur expert, but theropods, that could be anything from a velociraptor all the way up to a Tyrannosaurus rex. Theropods are primarily meat eaters, but not all of them are. Now, I'm not finding any obsidian in here, but one of the things when I was growing up, we got to learn about, of course, the different cultures that were here before we showed up. Ooh, there's part of somebody's reading glasses. Since that's man-made, we should probably pick it up and toss it. Here's another part of somebody's reading glasses. Looks like a 2.75. Yeah. And of course, we got a lot of stuff that grows here that's, plants you might not recognize or might not realize are there, or it might look gross and moldy to you if you don't know what the hell it is. But there's a lot of different lichens. A lichen is actually a symbiotic relationship between two different plants, and neither one of those plants can actually survive on their own. That's why it's symbiotic. Of course, here we got one with a lot bigger holes in it. We actually can see this one right here isn't actually a hole. It's a full fissure. It goes internal and actually acts as if it's a cave. Obviously, none of these rocks are going to be incredibly cool looking. Not like, all right, that tree we saw in town yesterday, that was a cool tree. It was all hollow, still had all that stuff on it. Ooh, is that not pretty? That is equilateral. If that was a person or a horse, that's some good confirmation. Now, of course, river rocks are not really my thing, are they? I got my interest in Native American artifacts from Rory Jepson. He actually, what we ought to do is con Sean Jepson into donating what Rory collected. Because Rory didn't just collect the Native American artifacts, he also went out and searched for the fire pits. He went out and every fire pit in Dual County that he was able to find, he documented not only where it was, whose property it was, but what direction the artifacts that he found were facing. Now, of course, as we get further along, there's going to be different types of river rocks. This stuff over here is a little bit different shapes. There's kind of some of the same stuff as far as the volcanic stuff goes, but these ones are smaller than those over there for the most part. These came from a different batch. When we talk about the sand pits in Chapel, Nebraska, stuff like this generally actually comes out of the sand pits. It doesn't literally come from the bottom of a river. The reason for this is because there have been rivers all over the country for billions of years, of course, and the terrain is constantly changing. The weather is constantly changing. You get glaciers, you get fissures, you get, of course, the water doing its own thing. That's how we end up with, like, God, what are they called? Fjords. What ends up happening is everything that's all the way upriver, all up through there, it travels down the Columbia or any other river, and it gets deposited downstream. Now, if you run into a heavy sandbar or possibly some heavy rocks like you run into over here, that'll actually alter the course of the entire river. Now, over there, you see how some of those mountains are pretty large? Well, some of the ones further along here, that one right there caved in about 600 years ago, and you can actually see on the side of it where it's etched in, where that part actually slid down. That changed the entire course of the Columbia River. Now I'm trying to see where Hood River meets with all this. I think it's actually over on the other side, because there's no way it stops right there. I'm sure it probably goes around that area. Now, what this is leading up to, like you see those rocks right there, those ones are harsh, they're jagged, they're sharp, but over time those are going to get worn down. Of course, when the river rises up, it'll cover those, it'll pull some of the dirt and the sediment, the rocks will settle down, but the sediment will flow further out. And then over time, as sediment builds up on top of those rocks, they'll end up getting buried. When the river decides that it's going to reroute itself to somewhere else, let's say, well, actually there's nothing really on this side of the river big enough to obstruct it. Maybe that mountain over there. If that part right there broke, you had a landslide and it brought it in, you'd actually get a backflow of the water here for a while. And then eventually it would erode through the loose dirt and it would leave the hard rocks there. And when that happens, of course, like I said, it buries everything. Buries all the sediment, buries even some of the plant life. And then, of course, millions of years from now, all of that sediment has been compressed and hardened and dried. And, of course, then it's as hard as a fucking rock. One of the difficulties with extracting dinosaur bones from the rock around it is that most of the time, those rocks are actually harder than the fossils that you're digging out of them. For example, there's a Ankylosaur, and this is the best preserved Ankylosaur that's ever been found. And because it is so well preserved as far as the skin goes, what had happened is it was, I want to say over by Madagascar, and this is probably wrong, but they found this Ankylosaur because they found a whole bunch of the, there's bones within the skin. They're called, God, what are they called? Something derms. Like an alligator. You know, the alligator has all those spikes on its back, and those are actually bones that are covered in a hard skin, similar to like rawhide. I mean, it's thick. It doesn't have much feeling in it. It's just a chunk of green skin over a chunk of white bone. Now we're back to the very beginning rocks that we started off with, aren't we? And we can see stuff. This right here was broken off across here. You can see a bunch of different shapes in it. Again, that's volcanic. It was formed from a volcanic eruption. And, well, as cool as this stuff is, mostly I'm just trying to waste time. Hopefully, within the next couple of days, we'll be able to get over there under the bridge there where those possible bones are, and maybe we'll even see if there's any other fossils in the area, possibly plant life. If it's a theropod bone, I don't want to mess with it. I'm not somebody who's going to be able to extract it out of the bone. I do have the artistic skill. I've got a lot of practice with Dremels, but at the same time, that should probably be left up to the professionals. Now, the story with the Ankylosaur is that it fell over upside down. So when it laid down in the sediment, all of those derms were actually embedded into sandstone. Now, what that allows them to do is that most of the ankylosaurs that we find, or most dinosaurs period, we don't have a casting or an imprint of their skin. So for the ankylosaur to be upside down like that when it died and then buried before it decomposed, we can even tell the spaces in between the skin, in between each of those derms. We can see a lot of different stuff. And there's also the fact that the bones are fully intact in it. All of the rocks that are in the stomach. Oh shit, my fucking phone died.